we want to go ahead and plug in the function that we saw on the previous video, and that was log. So you're going to go to your math function, go down to log base, press enter, and it was log base 2, and x was inside parentheses. So it should look like that, log base 2 of x. Now, we want to make sure our window is appropriate. So the thing about logs is, and this is something very important to know, press the window button. The thing about logs is that they're going to grow very slowly, or they're going to get slow, or they're, if it's the, in this case we're dealing with the inverse of a growth function, exponential growth. So this thing is going to grow very slowly. Whereas the inverse of a decay function is going to get lower very slowly. All right, so we don't need really big x values, if you will. We don't need our x values. I said that wrong. We don't need a wide range of y values. So notice I've got from negative 8y to positive 5y on the scale for y's. Now for our x values, I'm going to put negative 5 and 5 to 5, even though it goes on forever in both directions. All right, it's growing very slowly. We're not going to need to see everything. We're just going to need to see some pinpointed, the shift point basically. All right, so let this be your window. Negative 5 to 5, scale of 1. Negative 8 to 5, scale of 1. And now let's press the graph button. So you can see what it looks like when you graph it. Now notice that the asymptote is the y-axis. Everybody see that clearly? All right, it should be the same on your graph. Notice that there is a point on the x-axis that is 1 unit away from the asymptote. That's what I call the shift point. Notice how our curve is going through that shift point. In this particular problem, it always goes through the shift point. All right, so this is basically your parent log function. All right, when it comes to the inverse of growth. You can call this, if you want to, I guess you could call this the parent growth log function, if that makes any sense. All right, now let's go back to our y equals. Okay, and here what we want to do is we want to add a new function. So go down. We're going to add the function the second function that we had, and it was log base. So go to math, log base. It was a base of 1/2, so you can just do 1 divided by 2, 1/4. Sorry, 1 divided by 4 down there. We had an x minus what?
1.
Minus 1. And then we had a plus 2 on the outside. That's the vertical shift. Now, we don't want both of these to be activated at the same time. So I want to deactivate that first graph. The way I do it is go to the equals, press enter, and when there's nothing highlighted, that tells me it's deactivated. So look, this is what your screen should look like. You should have a little highlighted equals for the second one, not the first one. All right, now we press graph. So when we graph this one, look what happened. Now it's the inverse of a decay function. So it's going to go up forever, but it's never going to touch that asymptote. Also notice that my asymptote got shifted to the right 1 unit. Also notice that I'm going to have a point 1 unit to the right of the asymptote, but in this case, since it's plus 2, I'm going to go 1 unit to the right of the asymptote, up 2, and I should have a point right here. Okay, y'all see that? The point should be there. This is our shift point. All right, now, having done that, we could take the information from this and we could graph it on a sheet of paper. But we really don't need it because we can do a quick sketch of these on the paper with no problem. These are the 3 things I'm going to want on a graph. I'm going to want the asymptote, number 1. Number 2, I'm going to want the shift point. Number 3, I'm going to want the appropriate shape of the graph. So, this would be the log decay, if you will. It looks kind of like the original decay function. All right? In that, when I say, well, actually, the log, it's going down forever over here. All right? So this is the inverse of a decay function. The one we did before was the inverse of a growth function. All right, I'm going to stop the video now, and we're going to do some practice.